According to the National Electrical Code and most local building codes, a separate ground bar is required in the electrical panel after the transfer switch if the panel is not bonded to the transfer switch enclosure. Section 250.24 B of the National Electrical Code states that where a transfer switch is used, a grounding electrode conductor shall be connected to the equipment grounding terminal or terminals of the transfer switch. The separate ground bar provides a dedicated grounding point for the electrical panel, ensuring that all equipment connected to the panel is properly grounded. This is especially important for surge protection devices, which must be grounded to function properly. The inspector's question may be due to one or more of the following reasons: firstly, incorrect installation; secondly, code interpretation; and thirdly, previous job confusion. The ground bar may not have been installed correctly, such as not being bonded to the transfer switch enclosure or not using the proper bonding conductor. The inspector may have a different interpretation of the National Electrical Code or local building codes regarding the necessity of a separate ground bar. The inspector may be aware of the previous job where a separate ground bar was installed, but they may not understand why it was required or believe it is no longer necessary. Based on the current National Electrical Code and most building codes, a separate ground bar is typically required in the electrical panel after the transfer switch. This is to ensure proper grounding for all connected equipment, including surge protection devices. It is important to consult with the local building department and electrical inspector to verify the specific requirements for your area. Grounding is a critical aspect of electrical safety. It provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. In the context of a transfer switch and a generator system, proper grounding ensures that the generator, transfer switch, and the electrical panel it serves are all at the same electrical potential. This minimizes the risk of voltage differences that could cause equipment damage or electric shock. The equipment grounding conductor, often referred to as the ground wire, connects non-current carrying metal parts of the electrical system to the grounding electrode system. This includes the generator frame, the transfer switch enclosure, and the electrical panel enclosure. The grounding electrode system typically consists of ground rods, metal water pipes, or a concrete encased electrode that is connected to the earth. When a fault occurs, such as a short circuit between a hot wire and the metal enclosure of an appliance, the fault current flows through the equipment grounding conductor back to the source. This high current flow causes the circuit breaker to trip, interrupting the power supply and preventing the enclosure from becoming energized. The separate ground bar in the electrical panel after the transfer switch serves as a central point for connecting all of the equipment grounding conductors within that panel. It ensures that all circuits and equipment connected to the panel have a reliable grounding path. The National Electrical Code mandates specific requirements for grounding and bonding to ensure electrical safety. Section 250 covers the general requirements for grounding and bonding of electrical systems. Bonding refers to the practice of connecting all non-current carrying metal parts together to create an electrically conductive path. This minimizes voltage differences and provides a low impedance path for fault current. The size of the grounding conductors must be adequate to safely carry the maximum fault current that could occur. The National Electrical Code provides tables that specify the minimum size of grounding conductors based on the size of the overcurrent protection device. Proper grounding and bonding are essential for the safe operation of electrical systems. Failure to properly ground and bond equipment can create a significant electrical shock hazard. When installing a generator and transfer switch, it is important to carefully follow the National Electrical Code and local building codes to ensure that the system is properly grounded. This includes installing a separate ground bar in the electrical panel after the transfer switch if required, and ensuring that all grounding conductors are properly sized and connected. It is also important to consult with a qualified electrician or electrical inspector to verify that the installation meets all applicable requirements. Different types of transfer switches exist, including manual transfer switches and automatic transfer switches. A manual transfer switch requires manual operation to switch between utility power and generator power. An automatic transfer switch automatically switches to generator power when utility power is lost and automatically switches back to utility power when it is restored. Regardless of the type of transfer switch used, proper grounding is essential for safety. The location of the transfer switch also affects the grounding requirements. If the transfer switch is located at or near the service entrance, the grounding electrode conductor may be connected to the transfer switch enclosure. However, if the transfer switch is located remotely from the service entrance, a separate grounding electrode conductor may be required to be run to the transfer switch. The National Electrical Code also addresses the grounding of separately derived systems such as generators. A separately derived system is an electrical system that is not directly connected to the utility power supply. When a generator is used as a separately derived system, it must be grounded in accordance with the National Electrical Code requirements. This typically involves connecting a grounding electrode conductor from the generator frame to a grounding electrode, such as a ground rod. The grounding electrode conductor must be sized in accordance with the National Electrical Code requirements. In addition to the equipment grounding conductor and the grounding electrode conductor, a bonding jumper may also be required. A bonding jumper is a conductor that connects two or more metal parts together to ensure electrical continuity. Bonding jumpers are often used to connect the transfer switch enclosure to the electrical panel enclosure. The size of the bonding jumper must be adequate to carry the maximum fault current that could occur. When installing a generator and transfer switch, it is important to pay close attention to the grounding and bonding requirements. Failure to properly ground and bond the system can create a significant electrical shock hazard. It is always best to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable requirements. Understanding the specific requirements for grounding and bonding in your area is crucial for ensuring electrical safety. Local building codes may have additional requirements that go beyond the National Electrical Code. Therefore, it is essential to contact the local building department and electrical inspector to verify the specific requirements for your project. Grounding and bonding are complex topics, and it is important to have a thorough understanding of the principles involved. If you are not familiar with electrical work, it is best to hire a qualified electrician to perform the installation. A qualified electrician will have the knowledge and experience to ensure that the system is properly grounded and bonded, and that it meets all applicable requirements. The consequences of improper grounding can be severe, including electrical shock, fire, and equipment damage. Therefore, it is essential to take grounding seriously and to ensure that all electrical work is performed in accordance with the National Electrical Code and local building codes. Continuous learning and staying updated with the latest electrical codes and best practices are vital for anyone involved in electrical work. The electrical industry is constantly evolving, and new technologies and techniques are being developed all the time. By staying informed, you can ensure that you are providing the safest and most reliable electrical service possible. Remember, electrical safety is everyone's responsibility. By following the National Electrical Code and local building codes, and by working with qualified professionals, you can help to prevent electrical accidents and ensure the safety of yourself and others. In summary, the installation of a separate ground bar after a transfer switch is often required by the National Electrical Code and local building codes to ensure proper grounding of the electrical panel and connected equipment. This ground bar provides a dedicated grounding point for surge protection devices and other equipment that requires a reliable grounding path. The inspector's question about the separate ground bar may be due to concerns about a correct installation, different interpretations of the code, or awareness of previous jobs. To ensure compliance with the National Electrical Code and local building codes, it is important to consult with the local building department and electrical inspector. Proper grounding and bonding are essential for electrical safety and can prevent electrical shock, fire, and equipment damage. Always prioritize safety and work with qualified professionals when performing electrical work. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest edition. The National Electrical Code is a comprehensive document that covers all aspects of electrical installations, including grounding and bonding. The National Electrical Code provides detailed requirements for the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal parts. The National Electrical Code also includes specific requirements for different types of electrical systems such as generators, transformers, and motors. In addition to the National Electrical Code, there are also many other standards and guidelines that provide information on grounding and bonding. These standards and guidelines are developed by organizations such as the Institute of Electrical and Electronics Engineers and the National Fire Protection Association. It is important to be familiar with these standards and guidelines to ensure that electrical installations are safe and reliable. Grounding and bonding are not only important for safety but also for the proper operation of electrical equipment. Improper grounding can cause equipment to malfunction or fail prematurely. Therefore, it is important to pay close attention to grounding and bonding when installing or maintaining electrical equipment. When troubleshooting electrical problems, it is important to check the grounding system. A faulty grounding system can cause a variety of problems, such as voltage fluctuations, nuisance tripping of circuit breakers, and equipment malfunction. To check the grounding system, you can use a multimeter to measure the voltage between the ground wire and other metal parts. The voltage should be close to zero. You can also use a ground resistance tester to measure the resistance of the grounding electrode. The resistance should be as low as possible, typically less than 25 ohms. If you find any problems with the grounding system, it is important to correct them immediately. A faulty grounding system can be a serious safety hazard. In addition to the technical aspects of grounding and bonding, it is also important to consider the human element. The electrical workers must be properly trained and qualified to perform electrical work. They must also be aware of the hazards of electricity and take precautions to protect themselves and others. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By following the National Electrical Code, local building codes, and safe work practices, we can all help to make our homes and workplaces safer. Grounding is also essential for protecting sensitive electronic equipment from damage caused by surges and transients. Surge protection devices, such as surge suppressors and transient voltage surge suppressors, are designed to divert excess voltage to ground, protecting the equipment from damage. However, surge protection devices can only function properly if they are properly grounded. Therefore, it is important to ensure that all surge protection devices are connected to a reliable grounding system. Static electricity can also be a problem in some environments, such as computer rooms and manufacturing facilities. Static electricity can damage sensitive electronic equipment and can also be a fire hazard. Grounding can help to dissipate static electricity and prevent it from building up. There are a variety of methods for grounding equipment to prevent static electricity, such as using anti-static mats, wrist straps, and conductive flooring. The National Electrical Code includes specific requirements for grounding equipment in hazardous locations, such as areas where flammable liquids or gases are present. These requirements are designed to prevent explosions and fires. It is important to follow these requirements carefully when installing electrical equipment in hazardous locations. Lightning is a powerful force of nature that can cause significant damage to electrical systems. Grounding can help to protect electrical systems from lightning strikes by providing a path for the lightning current to flow to ground. However, grounding alone is not enough to protect against lightning strikes. Additional measures, such as lightning rods and surge protection devices, are also necessary. The cost of grounding and bonding is relatively small compared to the potential cost of electrical accidents and equipment damage. Therefore, it is important to invest in proper grounding and bonding to protect your property and your safety. There are many resources available to help you learn more about grounding and bonding. These resources include the National Electrical Code, textbooks, online courses, and seminars. It is important to take advantage of these resources to expand your knowledge and skills. Grounding and bonding are essential aspects of electrical safety. By following the National Electrical Code and local building codes, and by working with qualified professionals, you can help to prevent electrical accidents and ensure the safety of yourself and others.